Alright, good. Everyone. My name is Ben. We are the Thomas, the Thomas Mulvey Group. We are just essentially a project review committee, just looking at the Prezi wind farm. The objective of our task is to look at Bald Hills issues and complaints that have primarily been present and presented, looking at articles and history. And present possible sustainable solutions to optimise the project. So I'll just introduce, I won't be speaking, because I've already done steps, so I'll just give over to these guys to take care of. I'll first introduce Dhivyaa, who will be looking at the location and context to Bald Hills wind farms.
Thank you. Yeah, so I'll be talking about the background and location of the wind farm. And I'll also be going through the basic history of the case, like how it started in 2004 till 2014, before we actually get into the actual problems or issues involved. So as far as the background and location, Bald Hills Wind Farm is located 10 kilometers down south to Carolyn Lower, and it's near South Gippsland. So that's the region. I'll use the pointer. Yeah. So that's the region where all the windmills are located. So to be more clear, so to the north, there are about 29 turbines in region 1. The middle, about 5 turbines are located, and down south, 18 turbines. So that's the basic location of the windmills in the wind farm. So before looking into the issues or dealing with the issues, we thought that it's good to introduce the stakeholders, the people who are involved with the project and how it's going through. So, Bald Hills Wind Farm Private Limited is the owner, and it is only subsidiary owned by Mitsui & Co. Australia. So, Mitsui & Co. is the parent company, it's co-owner of the Bald Hills Wind Farm Private Limited. They are actively involved in investment and development of natural resources, and also they provide the strategic level planning and they give directions to the Bald Hills Wind Farm Private Limited just to help them out. And Rep Power Australia are the principal contractor, so they are in the contractual relationship between, with the Mitsui & Co. for like 10 years, but break for 5 years, but I think they've remained for 10 years. And most importantly, the government. So the Department of Planning and Community Development, Environmental Protection Authority, the Sustainable Environment Department, Big Roads, all of them are part of the state government. The state government is handling the project. And whereas in South Gippsland, the South Gippsland Shire Council is part of the local government for the project. So there's nothing, without the people. So community is another important stakeholder. So landowners, surrounding neighbors, local businesses, and Tarwandani Coastal Guardians, they're the NGO community group, they played a big role in the issue. So like I said, let's go into a history of timeline. So we started it out from 2004 till present date, how the project, what's been happening with the project. So early in 2004, so the wind farms were proposed to reach renewable energy targets. So since it was believed, the planning permit for the Bald Hills wind farm was obtained. And then in 2006, the Howard government Environment Minister Ian Campbell, he literally halted a $220 million permit because he thought the presence or the construction of such a big wind farm would cause death for the lives of the endangered species which are present in and around the area. But in 2009, Planning Minister then was Justin Mann. He had approved a 20% increase in height of the turbine. So the turbine from 110, but he approved a 20% increase to 135 meters in 2009. Whereas 2010, like I already said, the Tarwandani Coastal Guardians and the Minister of Planning, they go before the Victorian Civil Administrative Tribunal, VCAT, over the Bald Hills increase in height of turbines. So they increased the height of turbines, but they were unhappy and so they went to VCAT. Whereas in 2011 March, the Planning Minister then, Matthew Guy, he made a little changes in the amendment of the planning guidelines. So he included new noise guidelines. But the new coalition government in New South Wales decided to change the rights and power of the planning minister. So in April 2011, there was a new rule that the planning minister cannot involve in critical infrastructure regarding the turbines. But in May 2011, the Japan Mitsui & Co. still done to purchase agreement for the Borneo wind farm despite the depressed renewable energy certificate. So the certificate was not very good, but still they decided to purchase. So yeah, that was in 2011. So since they purchased, so 2012 work was officially to commence. And in 2013, it was believed that the tower and turbine installation would commence. And by the end of 2014, the wind turbines were believed to be perfectly functional. So let me pass over to Daniel, so that he goes through how wind as a representative.
Hello everybody. As Dhivyaa said, we'll be investigating wind energy as a form of renewable technology. So wind energy converts wind flows into electricity. Large-scale facilities are known as wind farms and are used generally to generate electricity for the national power grid. Generally with wind turbines we find 3 rotor blades mounted on top of a large tower. These wind towers can be anywhere from 50 to 80 metres in height. This is a general layout for a horizontal axis wind turbine. Wind energy is captured as wind currents pass through the rotor blades and force their rotation. And this in turn spins a shaft located over here, which connects the rotor hub to the generator over here. The generator converts the kinetic energy into electricity, and this energy can either be stored in batteries or transferred into the national power grid. Okay, this is a map of Australia demonstrating the various wind speeds across the country. Wind turbines are generally found in elevated or open natural settings. The optimal location for these wind farms being identified as parts of southern Australia. This is mainly due to the location of the roaring 40s, which is near southern Australia here. They demonstrate wind speeds of about 8 metres per second, which is widely considered to be the optimal wind speed for wind energy production. Here is a graph which demonstrates the various proportions of energy generation in Australia at the moment. As you can see, wind over here only contributes 3% of the current electricity generation in Australia. However, this is on the rise, and with projects such as Bald Hills, this is only going to get greater and greater over time. Okay, now we're going to introduce Temur to discuss the issues raised with Bald Hills.
Hi everyone, my name is Temur, and I'll be talking about the issues. Basically, we divided the issues into 3 categories: environmental, social, and economic. In environmental, we further categorize them into natural environment, physical environment, and cultural environment. Natural environment basically addresses the flora and fauna of the area. In the flora, the issue was about the removal of the native vegetation, which could have been avoided otherwise. And in fauna, regarding ground fauna, the issue was that it was destroying the habitat of the animals. And then there were, of course, bats and birds which were being stuck in the wind turbines. In physical environment, there were geological effects, erosion effects, and water quality constraints. In geological effects, the location was basically near a fault which would disturb the residents and spoil the ambience. Erosion effects due to the construction of such tall structures, obviously there was a foundation that was required, and for that it was thought that it might cause erosion. In water quality constraints, the fear of deposition of materials and sediments due to the surface runoff, and it would affect the surrounding reserve areas and drainage lines. In cultural environment, the project seemed to have some unacceptable effect on the Aboriginal cultural heritage and European cultural heritage, because this site was considered archaeologically significant and has a certain Midag family found some Aboriginal stone tools on their property, and they thought that there might be something else in the area which is yet to be discovered. Moving on to acoustic amenity, there was enormous noise coming out of the wind turbine in spite of the installation of sound insulators, which was causing the disturbance for the residents. And in visual amenity, obviously during construction, the construction would be visible from the houses, which was disturbing for the residents, as well as the flickering, shadow flickering from the turbines, and the grain effect from the blades was also a problem for the citizens. Site access and traffic was also a major concern because there were safety concerns during construction along the roadside, and drainage problems and removal of vegetation along the roadside during construction was also a major concern. Moving on to the economic effects, obviously due to all the issues that I mentioned, there was significant depreciation in the value of land for the local residents, and obviously the businesses and the hotels that were there, they were experiencing loss of profit because of the lack of tourism. And lastly, we have social effects, which basically addresses the division between the local community and the opposition of the community towards the project, and as well as the lack of opportunity for the community to provide input into developmentation and implementation of the project. Now Nishad will come and tell you about the solutions about these issues.
Thank you, Temur. Hello everyone, I'm Nishad, and I'm going to discuss the solutions to the problems addressed by Temur. And the first solution can be accepting the current approach by using the turbines, current turbines for generating electricity. So these turbines have some benefits, such as that it will contribute to the renewable energy grid target of 20% by 2020, and which will in turn produce 104 megawatts of power at that time, which will serve 62,000 homes, average homes. And it also reduces less amount of CO2 when compared to the conventional sources for production of electricity. Despite all these macro benefits, it overlooks the opportunities to address the complaints and issues which are faced by the community, and leaves no space for the innovation and future thinking. The second solution can be a new approach which consists of new technologies for producing electricity using wind turbines. First one is the inflatable wind turbines, which are helium-filled buoyant wind turbines suspended in air with the help of cables which are attached to the string tiles. These string tiles adjust the height of the turbine according to the altitude of maximum velocity of wind. And the altitude ranges from 1,000 feet to 2,000 feet, where the wind power generation is about 5 to 8 times than the generation on ground. The next technology is solar wind power, which uses solar energy and wind energy for production of electricity. It uses copper wire instead of blade attached to the turbines, and which collect the electrons which are coming from the sun at several hundred kilometers per hour speed. And it is estimated that it can produce 1 billion gigawatts of power by a satellite of 1,000 meters cable and sail of 8,400 kilometers. The third option can be isolating the wind farms from the vicinity of the residents, like placing them offshore, where the wind velocities are generally greater than the land velocities. Though this option is expensive, still it can be used for generating more power than land turbines. The other option can be isolating them from the places where residents are present and isolating from the migration paths of the birds, so that the birds for flora and fauna can be saved. Thanks a lot. Now I'll transfer to Daniel for the third solution.
Okay, so the third solution for the Mulberry Hills Wind Farm was a redesigned and modified approach. So we categorised the various issues in terms of social issues, environmental and physical issues, as well as economic issues, and solved them individually to get a better grasp of the overall new solution. Okay, so the social solutions. We implemented a stakeholder analysis to have more vigorous communication channels and community timeline with project gateways. This was done to better enhance stakeholder management. Accurate, reviewed and concise information, knowledge-based concerning the design, decisions and aspects of the wind farms is also imperative to avoid miscommunication, conflicting information and ensure the adequate sharing of knowledge across the project. The Department of Sustainability and Environment consultation guidelines were to be utilised in order to mitigate any fragmentation between parties of the community as well, which was one of the key issues on this particular project. Okay, environmental and physical solutions. So in terms of environmental solutions, we utilise the adaptive management model to propose a solution for this particular problem. So both the present and future landscape design strategy will need to be first conceptualised, adequately envisioning the present needs of the site whilst allowing the flexibility to incorporate changes to the landscape, biodiversity and vegetation in the future. The pre-existing surveys and ecological studies conducted as part of planning should be conducted in a more substantial and thorough manner, extending the monitoring and ecological survey programs over a longer time frame. The Bald Hills Wind Farm thing integrate with compensatory replanting and vegetation in designated areas. Monitoring process needed to be established to ascertain the continuous performance of changes to vegetation and landscape. However, this required more personnel and resources, which could be a negative attribute in the future. Continuing analysis with a regular monitoring scheme in place for fauna and vegetation. Currently, a no harm to net gain scenario is achieved. This establishes innovative approaches and establishes systems and schemes to add capital to the natural environment, which is the ultimate goal of this particular approach. Potential evolution to the site over the course of years is to be recorded and monitored. Substantial documentation data can then be reviewed and shared to reduce the biological impacts in the future and be amended accordingly as the conceptualization process commences all over again. Okay, physical environmental concerns and solutions. So in terms of the two major issues we have, in terms of acoustic amenity and visual amenity, we approach this utilising more strategic triangle. So on an operational context, we could have redesigned the wind turbines, making them more aesthetically aligned with the landscape. However, this may affect the efficiency and operation of the wind turbines, so this approach might need to be considered differently. Authorising context. So non-complements areas of acceptable acoustic levels should be defined in collaboration with the local council. It is recommended that Minister for Planning should retain ongoing responsibility for monitoring and enforcing acoustic conditions, providing support to local councils. Further direct involvement and authorising influence from EPA will also be required in monitoring and enforcing acoustic conditions. The benefits of this particular approach would be to protect the interests of residents by ensuring undisturbed sleep and mitigating any risk of acoustic disturbance. However, some of the drawbacks of this approach would be redesigning may sacrifice wind turbine overall efficiency and energy production, which is a prime goal of the Bald Hills wind farm, and greater consultation will be required with more authorising players and processes. Okay, so the site access and traffic congestion issues will also solve using more strategic triangle. So authorisation included the DSE and local council authority head. Included traffic management plans to be specific and more detailed with land permits provided and project gateway inspections. In terms of the operational capacity of the project, we required service roads to be created which were only accessible to Bald Hills staff. Main roads are only used during low traffic conditions. Entrance and exit site plan with operational measures put in place, and contingency measures such as insurance and bonds to be placed for any damaged vegetation, land, etc. The benefits of this particular approach include road user and community satisfaction, improved public image of the project, enhanced control over the project operations, and financial savings by avoiding damage to roadside vegetation and the existing roads put in place. In terms of economic issues, these were solved by providing either infrastructure or financial incentives. Infrastructure incentives included Parks Victoria and the stakeholder landowners entering a partnership to help negotiate and determine possible value, content and design of combined wind energy farm and park that surrounds the Bald Hills area. Compensatory scheme for the community with additional amenities through parks can help return any loss in land value as a result of the wind farm being built. Some financial incentives to consider Compensation to landowners in lieu of land value losses. This could be either provided in the form of a single payout or financial assistance to relocate homes, businesses, etc. Or incentives for people to live near the wind farm could be created in the form of tax reductions, financial assistance, etc. However, the issue with this particular approach is that it may require government assistance and create lengthy and unnecessary delays. So, the optimal approach that we considered was the redesign and modify approach. This was largely considered due to its cost effectiveness. It directly addressed the issues faced and made use of existing benefits while moving forward with sustainable solutions. And below we just summarised the various social, economic, environmental and physical solutions and their contributions to this particular approach. Okay, so this concludes our presentation. Thank you all for listening.